Hi guys, welcome to today's little tutorial about designing NoSQL compatible schemas and interactive reporting with Saiku. In this little tutorial, we're going to go through attaching Saiku to Apache Phoenix, which is a column store for HBase, so you can run queries over your HBase to use SQL in a performant-ish manner. And so we're going to go through getting data. Well, the data's in, but just explaining how the schema works, how you interact with it, how you connect, how you create a Mondrian schema, and so on and so on, which will allow us to obviously view the data that's held within it from within Saiku, and then obviously perform interactive analysis over the top. So let's get started. As you can see on my screen, it's not very exciting, but it is a terminal. And we're going to use some freely available airline data that allows us to analyze arrival times and late arrivals for US aircraft over time. We're going to keep it simple. We're just going to do January 2015, but obviously you can scale up when you require. So we got quite a big table here, but it's a standard SQL table created within Apache Phoenix. And so we map our CSV columns to database columns, and then do a big fat insert from there. And so I don't need to go through all the columns itself, but you can see how that works. And then down at the bottom, we use the PSQL interface to allow us to suck up all the data from a very large CSV file into the Phoenix data store, which is on my server up in the cloud. And so once that runs, as you can see, I ran it earlier, and you've got CSV upsert complete with 468,889 rows of airline data for January 2015 imported into Phoenix. And you can prove that if you go into a SQL line client, and then you can do select count star from fact on time. We'll go away and count. Okay, this one's a bit short, but you can see that there's a load of data in the table, which will allow us to then perform analysis over the top of it. So with all that data ingested into the database, we can then look at getting it into Saiku. And so if I just switch screens quickly. So Apache Phoenix is a plain SQL interface, so you can connect to it using either Saiku CE, Saiku EE, either will work. You just provide it with the correct URL and parameters, and it will go away and connect to your Phoenix service. I'm going to use EE because that obviously allows us to design schemas from within inside the platform and negates the need for text editor, but you can go away and try this on CE and it will work exactly the same. So up on the toolbar, I can select my schema designer, and so the schema designer is still in beta. It's still got some kinks and issues, and we're trying to work on the usability to refine that a bit. But it's very functional and does exactly what it's supposed to do. And so if I create a new schema and I call it on time, I then get presented with connection details. And so obviously the connection details are the connection information that I need to connect to my remote service. So the driver is a Phoenix driver. and then the URL is that one there. And so if I then hit connect, it will go away and connect to the Phoenix box. And then Phoenix doesn't really have an understanding of databases and schemas, so you just select default, and hit the get tables button. Off it goes. And so you can see it's returned a bunch of tables from the Phoenix database. Within that, you've got stock symbols, web stats, which are the demo bits and pieces that they supply, and also the fact on time that I created. And so we'll assign it a random key. It doesn't really matter because we're just doing a one table cube, but we select the fact on time. We can then start adding dimensions to our cube. So we'll go. I've got a pre one I did earlier, but we'll just go through this just to demonstrate how it would work. So if we wanted to create a departures information dimension, we could then drag fact on time in, and we'll call it departures. We can't select a key yet because of the fact we haven't created any. So let's go ahead and create a key, and we'll call it ID, and that is the unique calendar, unique carrier, the flight date, and the tail number. So we can select multiple compound keys, and then we can select a name for it. So, and then we'll go through and add a couple more. So we've got, we're going to do departures. So we've got departure state name. So we'll call it state. We've got departure city. So find that one. Where's it gone? There it is. Departure, sorry, destination, city name. So city, add that one. And then we can have the destination airport itself as well. So we got attributes into the dimension, and then we can create a hierarchy. If you just have a simple bunch of different attributes, you don't have to create a hierarchy. You just within here select the has hierarchy button. But because we have state, city, and airport, we can create a distinct hierarchy. So we'll call it departures. All departures. Hit the next button. And then from here, we can select state, city, and airport. If you put them in the wrong order, you can always drag them around to rearrange them, but they obviously have to go in the logical sort of drilling order. Hit the add button. We've then got our departure hierarchy. Departures as well. So once we've created our dimensions, we then need to obviously attach them to a cube. So in the new version of 3.2, the measure groups are now exposed. So you can have a bunch of different measure groups that group your measures into specific buckets. So arrival measures, departure measures, aircraft measures, they can all be segregated into different distinct measure groups, which obviously if you have a lot of different measures and metrics, just can help visibility, can help people understand what's available to them. So first one, departures, and then we select our fact table. From the measures, we can then select from a wide range of measures. So we'll look at departure delay. We want a sum, and so we can then add our measure, and then we also need to link it to the dimensions that are available to that measure group. So we select departures. Because we're using the fact table, you don't need to select a foreign key. It obviously all comes from the same place, so that blanks itself out. Hit add, hit update. Away it goes and updates. You can also select the cube name. So bytes. And so this will go on, and you can obviously create a tricky, or as complex or as easy a cube as you wish. Once you're happy with it, you can hit the save button. And then if you go back up to the toolbar, you can hit the create schema button, and that will go and create the schema within the, save it within the repository itself. So if I then go to the admin console, you can see that it's created this on-time schema. Now, if you want to go back and edit it later or manipulate it further and add more complex elements to the schema, you can hit the download button, and it will download the schema for you to your local machine. And then from there, you can obviously manipulate it and then send it back to the server. So you can tweak it, hack it, change names, labels, whatever you want, and then just post it back to the server at a later date. Or of course, if you're developing somewhere and want to put it onto a different box, you can just download it and upload it to another server nice and easily. Once you're happy with your schema, we then need to create a data source. And so we're using the on-time data. So from in the data sources area, you then need to create a data source that will allow us to connect to Apache Phoenix. So we give it a random name. This one, unsurprisingly, I've called on time. The connection type is Mondrian. If you're wanting to connect to Microsoft Analysis Services or Essbase, you can select XMLA. If you want to connect to a Mongo data source, you can select the Mongo type. And so depending on which type, if you just go for a standard JDBC connection to MySQL, Oracle, Phoenix, whatever, then you just use a standard Mondrian type and give it to JDBC URL, which is the same as the one we used in the schema designer. Then in the schema, you select the schema that you want to use. And so in this case, this is the one I prepared earlier. So it's Phoenix 2. Again, the JDBC driver. That's pretty straightforward JDBC stuff. For Phoenix, username and password doesn't count, but you can, obviously for some databases, you need to enter a username and password. So once you've got all that set up, you hit the save button. If you drop yourself into a standard query design window, you can then hit the green refresh cubes button, which will clear the cache, will clear the database, and allow you to refresh the schema. Now, if your schema is accurate, correct, working, and the data source connection definition is correct, then you'll be given the ability to select your cube from the list. So here's one I made earlier. This is running live over the Phoenix database, as we discussed earlier. And as you can see, is a little bit more complex, not massively so, but a little more built out than the version that I just demonstrated there. But the principles are the same. We've got departures, we've got origins, planes, dates, airline types, all that type of stuff. And this means that you can then quickly and easily start analyzing your data over the Phoenix data source, which is cool. So we can do analysis on Hadoop quickly and easily without using any type of text editor or anything like that. We've created everything within the platform. And we can now start analyzing it. So if I wanted to know average departure delay for a airline, so if I open up the airline dimension, you can see here, this is just a multi-attribute dimension. I didn't define a hierarchy, so you've just got a bunch of attributes hidden away there. And then I wanted to know it by carrier, so if I put that onto rows. And so whilst Phoenix may not offer the same performance gains that using Exasol or another column store database that's designed for ultimate query performance, it does allow you to perform interactive analysis in reasonably quick time over large data sets. Phoenix, of course, allows you to also add indices and do various optimizations, which are out of the scope for today. But there's an awful lot of tuning you can do to make Phoenix run well over large amounts of data. And so from this point, you can then obviously start chopping around data, visualizing the data, seeing what is available to you. And so currently, this is a very simplistic query. We've just got carrier, an average departure delay. And so we can see whoever F9 is, has the largest departure delay of an average of 18 minutes for January, which probably isn't the best. American Airlines coming in at 10.5. So you can start to delve around and see what's available to you within the data. If I just flip back to the table, we've got this dimension here, which is the departure time block. So you can see where the delays occurred more frequently. So if I just flip this around, for American Airlines, you can see that the largest average delay occurred around 6 o'clock, 7 o'clock rush hour, I guess. And so you can instantly see that may not be the best time to travel. If we go back to the table, you can see up here that this block in the 6 o'clock area clearly has the largest delays of the day, whereas clearly traveling early doors at 6 o'clock in the morning, will allow you to travel hopefully a bit more on time. And so you can start analyzing your data over Phoenix. You can start playing with the data to see what's available to you. Take that one back out and say, okay, well, I'm interested in seeing where the delays were by state, which is the worst state to fly out of by carrier. I can then see that up here with the highest is New York, Maryland, and Connecticut. So, you can start to figure out where you might not want to travel from within the US at a given point in time. And of course, a line chart isn't necessarily the best way of being able to view this data. And so we have a bunch of different chart types over here on the right-hand side that will allow you to visualize your data differently. So if I wanted to see it broken down into lovely wheels here, I can then see the larger chunks and the single colors where you've got the larger delays per state. And so because this is still running SQL, it means everything that's available that would normally be available within Saiku is available to you as users. You can drill down, you can export this data, you can run the stats over it, you can run all the charts. But of course, you can start doing filtering and more complex stuff. So if I start looking in, if I click on the state icon here, you can see that it pops up the selections. So from here, I can start narrowing down what I want to see as a user. And so if I wanted to filter just on specific states, maybe all the ones beginning with A, I can say I want to include those in my query, and then click on the OK button. And then it'll go away and talk to Phoenix again and say, I just want a subset of the data. One of the things you can do, obviously, because it's running SQL, is use aggregate tables alongside all the standard data optimizations you can do. Mondrian allows you to insert inline aggregate tables. And so if you have a large amount of data that needs aggregating up for performance reasons, even though it's in Hadoop, you can still do it in exactly the same way that you would usually do aggregations within any SQL database. So as you can see, the query went away and ran. You can see up in the top corner, it took 5 seconds to run, which isn't bad over 500,000 rows of data. You can also flip it around and say, okay, I want to exclude all the ones with A, but include everything else. And so, you can do an exclude type query. And then also for some users, they find it easier to interact with the table as opposed to this menu on the left-hand side. So you can say, okay, I want to include cities. And so it will go away and add city to the level. This will take a while because it's got a big cross tab to do. But as you can see, it's added the city level to it. And then you, as a user, say, well, okay, I'm only interested in sort of down here. So, well, let's keep and include. Sorry, let's remove the state level because I'm only interested in city level. And so you can see users can interact with the table using the context menu, which makes it a little bit more intuitive. They can also filter and chop all that type of stuff around as well from down in the table area. Saiku also allows you to do zooming on specific charts. So this one obviously has quite a lot of data where you might want to see a smaller subsection, and so you can drag, similar with the line charts and other bits and pieces as well. The black arrow in the top allows you to do top count. So if you just wanted to know the top count by departure delay, top 10, sorry, you can select the top, and so it'll go away and bring back the top count for your query. So once we've got all that type of stuff done, and we've got some ideas about how we want to manipulate our data, it's obviously quite useful to be able to display this type of stuff in dashboard type framework. So new to 3.2, we've been working on this dashboard framework, which will allow users to display the data in multiple reports on the screen at one time, joining filters, manipulating chart types, all that type of stuff. So if I click on the dashboard icon on the top and then select new, you then select, you enter the number of rows and columns you want in your dashboard. This isn't fixed. You can add and remove them. It's just a way to get started quickly. And then from here, I've told it I want 1 row and 2 columns. And so as you can see, I've got 1 row and 2 columns. And you've also got a space to add a title at the top. From there, on the left-hand side, we've got the reports I've saved. Okay, so dashboards in Saiku are made up of the reports you've saved. You don't have to create reports specifically for a dashboard. You just import the ones that you've used in different places. And so if I drag in delay by state, you can see its default view is a table type view, which in this instance isn't going to be the most useful, but for smaller data sets or where you want a summary, a table type view might be of use. Side, so we've got 2 sets of tables. I want to see charts, so the default chart I saved for this one is a big fat wheel chart. But as you can see, if you go into render type, you can change the chart options by selecting a different chart from the list. You select a different one, it'll go away and render it with a different type of chart. Once you've got all that set up, you can then define the titles, the filters, all that type of stuff. So I want to add a title, so I'm going to call it delays. And then we've got delay departures and delay arrivals. So you can start to change the layout and the design of the dashboard. If you want to change the widget size, you can drag them around and make them different. You can also, as you saw me do it by accident, you can also change where they are positioned within the dashboard. So it's quite flexible. The aim of it is to allow users to not have to write any code. It's supposed to be a simplistic way for users to be able to design dashboards, but obviously quite flexible as well. And so from that, we want to be able to filter our different reports. And so in one of the reports I saved earlier, I saved a parameter at state level, which unsurprisingly is called state. And then I want to be able to filter by state. So I'm going to create, you can see from the list, there's a few different types. And so within that list, if I select radio button, text box, drop down, default, or drop down multi-select, they allow me to select different types of pop-up. And then in that filter, you can either create a predefined list, so I could just type in a bunch of different state names and it would use that, or I can tell it to look up from either the current level or override it and look up from a specific part of my cube. And so in this one, we're looking at destinations. So select the states. You can then decide to link it to different reports. So if you've got multiple reports within one dashboard that all require the same filter, then you can select the report you want to link it to from the list and select what parameter, because obviously it might have a different parameter name, but it still does the same thing. Select that, save that, and from there, you can then obviously have a look at your dashboard. So Save that. Yeah. So there's a couple of ways of being able to display the data for Saiku dashboards. You can either see it in its usual embedded mode. Obviously, this is within a tab within the main Saiku user interface, and so you can see, the data that's displayed within that couple of reports. If you want to be able to filter it, you can click on the filter button, open up the filter panel on the left-hand side, and then start selecting the different dates in this case you wanted to filter by. So obviously every time I go and click on a filter button, it's going back off to Phoenix, getting the data back from Phoenix, running a query, and then doing anything else it wants to. You can, because it's a multi-select, I can use control to select a couple of different types of states. And you can have as many filters as you want. So you can obviously do time-based filtering, you can do state-based filtering, you could do whatever you want in this dashboard. And if you join the two together, you can then have them updating in sync with each other. So it's a flexible way of being able to display multiple reports on a screen. But it's not quite finished. We also understand that you might want to be able to show this outside of the Saiku user interface, embed it into a website or onto an intranet portal, or of course be able to display it on a TV or something that, a large scale screen where you want to be able to show up-to-date information. So if I just go back to this screen here, and we'll go into open, and then we'll find it. Down the bottom of the open dashboard screen, you can see you can open it in a new tab, or you can open it in a new window. So if I select open in a new window, you can open the Saiku dashboard outside of the main Saiku user interface, which of course removes the extra clutter that goes around it. And so for embedded scenarios, you can obviously keep it nice and clutter-free and look like it's part of the same application. So, in a nutshell, we've created analysis of flight data over Apache Phoenix, obviously, which is Hadoop-based. You can do it over JDBC. You could do it over MongoDB. You can also mix and match, of course. If you've got a dashboard and you've got multiple different data sources, you don't necessarily have to constrain yourself to taking everything from Hadoop. You might have some sales data in a relational database. You might have your larger scale data in Hadoop. You might have some inventory analysis stuff going in Mongo. So you can use a number of different data sources. You don't have to use just one type of data source when you're creating your dashboards. And so it's quite a flexible tool. Because it's all HTML based and CSS based, you don't have to stick to the color scheme we just defined. You can go away and change the CSS, and it will update. So you can theme it and brand it very easily, along with obviously embedding it into your own application. So there we go. There's a run through of creating some dashboards with Saiku 3.2. We've got a release coming out later today, which will tidy up a few bits and pieces and add the title stuff into the dashboard framework. So look out for that. Make sure you download the update. And of course, if you have any questions, comments, or what have you, then feel free to get in touch with me through the website or give me an email, tom.barber@meteorite.bi. Thanks for swinging by, guys. Speak to you later.